Hey guys, and welcome to /Rex Games. So this is going to be part 4 of my Studio Native Networking series. Thank you for your patience. I had some other tutorials to get out of the way before I got to this, and looking at my planning on this episode, there's going to be quite a lot to cover. So in our last tutorial, we covered login, which basically just told our server which players were logged in and which players were just connections and nothing more. So in this tutorial, we're going to be creating a very basic main menu. We're going to be getting our player to that main menu, and then we're also going to be actually joining a game. And when we do join the game, we need to make sure that that player entering knows about all the other players that are currently in the room, and all the other players that were in the room before knows about this new player. So those are the kind of things that we're going to be focusing on. So as always, I've got my server on the left and my client on the right. So let's head off into serverland, and the first thing we're going to do is create our player. Object, player. And let's initialize some variables over here. Start off with a player identifier. Set this at 0. We need a player name. Set this to blank. We're going to need a boolean called player in game. Set that to false. And we're going to save our player socket right over there. Set it to 0. Cool. So these are the variables we're going to be using. I'm not going to be creating a enormous data structure to hold all the client information. I'm actually just going to be storing any information that we need to know about a player in its own player object right over there. So that'll also speed up the deletion of our sockets when a player disconnects and the addition of new players and such. So there we go, create is done. Now let's head over to our object controller, and in its create event I want to change a few things. Firstly, sockets over here, it's not that very descriptive. Let's call this global players. Alright, so now we know exactly what that list is all about. Then I'm also going to be creating a variable here called player ID counter. Set it to 0. So every time a new player joins, it's going to give him an ID, and then it's going to increment that, and so on. So everyone's going to have a unique ID too. So that's going to be really cool. And now because we've done this, we need to make sure wherever we're using sockets, we need to change it to global player. So that's in our game end event. This one. Cool beans. So now into networking. So currently, let's have a look here at our connect. We grab the socket of the person connecting and we just add it to our list. So we need to do a lot more things in this. So let's nuke line 6, add a lot of space, and let's add some really cool code. So first things first, every time a player joins, we're going to be incrementing our player ID counter. After that, let's create the player with instance create. Just put it at 0, 0, doesn't really matter. Type object player. Okay, so those variables that we initialized in the create, let's override them over here. Player identifier equals player ID counter. Player name equals blank. We'll get that later. Player in game still equals false. And player socket, I think it's spelled socket, equals socket. There we go, very cool. So now as before, let's add, let me do that. Let's add this player to our list of global players. ds list add global players and the socket. There we go. So now that we've created an instance of this player on our server side, we need to send him this ID. He needs to know a piece of information about himself. So send player ID. We start off with a buffer seek of the global buffer. Buffer seek start, was it? 0. Buffer right. Global buffer. Buffer U8. And that's going to be a 4. I think, let's have a look through script, handling incoming packets. See what's the next one, 3, 4. Cool, we can use 4, we'll use 4. So we're sending a 4. I'm going to copy this line, fix that, fix that. Here we're going to write a U32, and it's going to be our player ID. Just the player ID counter. And lastly, network send packet back to our socket. What do we want to send? Well, our global buffer. How big is this buffer? Buffer tell. Global buffer. Alright, so let's get rid of this white space, and it'll say new player is connected. So I actually want to go into this draw event and add some stuff here. I'm just going to speed this up. It's not really necessary for you. And there we go. So basically I'm just drawing out the information of the player so that we can see certain things change about it whenever we do testing later. Cool, so now we need to head over to our client. Script handle incoming packets. So we sent a 4. So let's create it here. Case 4. There's our skeleton. I'm going to say global player ID equals, and let's grab this one. And it was a U32. There we got our player ID. And let's show a notification. And let's say our player ID has been received. Alright guys, so there we go. We now have our player ID. One more thing while I'm here on the client is I've added some sprites. We've got our button join and our button exit. There we go. So we're going to use these to join the game and log out or exit. And now it's back to the server. So let's go back to controller. Let's have a look at our disconnect. So we beefed up our connect. We need to do the same with our disconnect. So currently we just remove a socket from our DS list. So let's remove all of this and add some new stuff. Var index equals DS list find. I think it's find index. Oh no, capital L. Let's make this bigger. Find index, global players, socket. So we're going to look for that socket in the global players DS list. That's going to give us a position between 0 and n. N is the last element. So if our index is not equal to -1, so that means we've found that element, socket, in there, then it's not equal to -1. DS lists delete. Let's do global players and index. So then let's get some info about this player leaving. So var player leaving ID equals 0 with object player. So remember, at this point, all the information about this player is stored in object player. If player socket equals socket, then player leaving ID equals player identifier. So now we've got the player ID of the person leaving. So in this situation, we now need to notify all active players, all players in game and whatnot, that this player has left, so they can remove a remote instance of this player on their side. So I'm going to do that after this with. So now we have that information. Let us notify all players. Okay. So I'm going to have a for loop. Is less than DS list size global players I++. It's going to be cycling through all our players. And with each of them, var stored player socket equals ds list find value on global players and position I. Cool, so now we have the socket of a player. Now remember, we've already removed this person leaving from our list of sockets, so we don't have to check that it's not him, which is really nice. Let's tell all our players about something. So I'm going to steal lines 21 to 24. Paste that over here. Replace socket with stored player socket. So it's going to be sending to whichever player is represented by this index in our players DS list. I'm going to be sending the player leaving ID. And we're going to be sending it to a 5. So on our client, we now have 1, 2, 3, 4, and 5. 5 is going to be our new one that we're going to be making. Keep that in mind. Let's just double check. Seeking to the beginning of our buffer. We've got our 5 going. We've got our player leaving ID, which is a type U32. Everything looks good. I don't see any typos. I can't guarantee that this will work straight off the bat. We might have to fix some errors in the end, but that doesn't matter. That'll maybe I can teach you a thing or two about finding out where your errors are occurring. So that'll be a bit of a bonus, in a sense. So the last thing to do is to delete our player. So I'm going to copy this code. You can put it in there, I guess, if you want, but I want to keep things as separate as possible, just in case this piece fails. I don't want 2 things failing at once. It's going to make it harder for us to find the problem. So if player identify equals player leaving ID, then pretty much just instance destroy. We'll clean these things up as we go along. Cool, so let's bounce over to the client again. Remember, we're sending a 5 and a player leaving ID. It's pretty much the same as when we were sending our player ID. Cool, so accept that. Go to handle incoming packets. Let's just copy case 4, paste it in here, create 5, remove this line. Let's create a variable here called PID, and they're rereading in the player leaving ID. Now, before I go any further, let's just accept that. And in our objects, let's create something called object remote player. So the remote player is going to be the other person in the game. So remote player needs some initialized variables. For example, a remote player name and a remote player ID. Now I'm giving these very long names. I just want to be as descriptive as possible, because when we do delve into the more intense bits of our handle incoming packets, the one biggest problem that will bite you in the ass is going to be variables conflicting with each other. It's very painful, and it does happen. So I want to be as specific about what is where, just so that we don't end up with the same variable names and the game can end up breaking, even though technically there's nothing wrong. So let's keep things as descriptive as possible. Then in our draw event, draw set color, let's just see red because everyone else is a bad guy. Let's draw a circle, X, Y, 15 radius, 15 radius, outline true, and let's draw text, Y minus 25, string, remote player name. There we go. There we go. And then below that, let's draw our remote player ID. And let's put that at minus 50. That'll be even above that. Let's put this in order. Just like that. Cool beans. So now that we've got a remote player object, I can go back to script handle incoming packets, back to case 5, and say with object remote player, if remote player ID equals PID, just like that. Then we can destroy them. Alright, so this may seem odd, but this, remember, is the disconnect. I know we haven't exactly created any instance of object remote player via code anywhere. But this is just to ensure that when they do exist, and the player does disconnect on his side, we need to make sure that there's no phantom player on our side that we're pretty much interacting with and shooting and destroying, and then we don't get points because actually that guy has left long ago. So that'll disconnect him from our side. There's some little things that I want to change. If we're going to menus, going to login, button login, let's go over here into left pressed, expand this. Cool, so we've got our username, password, hash that up, and we sent it through the 3. At this time, I also want to set our global name to that of player username. Because when this does succeed, we're going to go to the next page, and I want to use global name and global player ID, and not tie those to any instance of any object, because what happens if we're in a room that doesn't really require an object that moves, right? So you still want to interact with our server. We still want to hold on to certain pieces of information about ourselves. And then here, when we are sending a 0 and a 3, I want to actually send buffer right global buffer. This is a buffer U32. I want to send my global player ID. Let's say, for example, let's assume, for example, that this login succeeds. Now, I'm already sending my username. What's the point of getting a response from the server saying, okay, now you're logged in, and now I say, okay, well, now that I'm logged in, I can send my name. It's an extra little bit of information that we've already sent. So how about we tell the server our ID, just in case it passes, then we can also tell that server to look through all its instances of object player and set my name to that of the username I'm passing through. So now we need to go to the server and look at 3 and make sure that the first thing we grab is our ID, and then we're going to use the retrieved username and set that value up on the associated player. So back to serverland. I know this is back and forth, that's just the way it goes. Handle incoming packets. Let's go to our 3. So first we have var PID, and let's copy this and set that to buffer U32. Great. So check if player exists, bloody bloody blah, response equals 1. That's fantastic. This means it was successful. So, oops, with object player, going through all the object players, well, if the player identifier equals PID, then let's set our player name equal to player username. Great stuff. So there we go. In one request, we have logged in and updated our username. And updated a very integral piece of information about ourselves on that server. So now we're going to bounce back to the client, and we're going to be creating our local player. Let's just duplicate our remote player. So this is the player we move around. So any movement code, you smack right in here. So he's not going to have any initialized variables because those are stored globally. We are going to have a draw. And that's just going to be drawing a nice green circle for us. We already know certain things about ourselves, so don't worry about that. Then let's create a folder in menus called main menu. Okay. And let's create our buttons. Let's do btn, login, and object btn, btn exit. Give them the respective sprites. There we go, login. Let's call this one join. Sorry, not login. Okay. And join is going to take us to, let's see, mouse left pressed. Room, go to room, game world. And exit, just is going to exit the game. There it is, end game. So let me go to rooms. Let's create our room here. Let's duplicate the game room. So I got my dimensions, settings, room, main menu. Let's expand this, creation code. Yeah, that can stay there. Let's bring in our objects. Let's put join over there, and let's put exit here. Let's see if we can get them sort of center. That looks fantastic. Now we need to make sure that when we do log in, we're not going to the game world. We actually want to go to the main menu. So on success here, case 3 room, case 3 line 36 of handling incoming packets on the client. We want to remove this one and replace it with main menu. And actually the same with auto login when we register. And then when we go to our game world, let's strip this down. Let's open this up. Let's change this to joined game world. Cool. So while we're here in the room game world, actually let's go to creation code. And let's create our player randomly in the room. So with instance create random room width minus 60. Make sure we're not going outside of the room. Plus 30. Don't worry, this is just going to put us within reason. Random height. Let's make this bigger. Room height minus 60 plus 30. And object local player. Let's see our brackets. Bam. Cool, so we got our random there, and we got our random here, and bloody blah, we're creating that, cool. So with this fresh instance of local player, player.name equals global.name. You know, actually these variables are stored globally, so I don't really need to set anything up here. Let's get rid of those. Just create it randomly somewhere. Then tell the server about it. Now I'm going to cheat and I'm going to go into something here and just steal the code that we use to create a request to the server. Let's grab this one. There we go. Go back to game world. Paste something in here. So we're seeking to the beginning. Let's see, what do we have available in here? 3. Now we have 1, 2, 3. On our client side, we got all the way up to 5. Now I like to keep what I send the same as what I receive, so that when I'm stepping through the flow of my networking game, I know exactly what's going on. So let's go for the 6, because that is available on both the client and the server. So let's put a 6 in there. So this is basically tell the server we're joining a game. And we just need to send our player ID, so I can actually delete that. So remember, 6 is taken in the player ID. And we're writing that to the socket, object controller socket. Alright, so let's jump back to the server. Remember, reading in player ID, add a 6. Server side handle incoming packets. Case 6. Let's make our skeleton. Lots of space, break. Okay, so this is going to be a big case. There's a lot of stuff for us to do here. And in the end, you'll be like, wow, that makes a lot of sense. Trust me, it will. So first things first, let's grab our PID. let's initialize something called pName. And you guessed it, means player name. With object player, all players currently on our server. If player identifier is the same as PID, so we're finding that player. If we find him, well, let's set his player in game to the opposite of what it is now. You see what I'm doing here? I'm going to be using this case of 6 to change between whether a player is in game or not in game. We can just keep sending a 6. We don't have to have a 7 also to set it to false and a 6 to set it to true. Because I'm going to assume that at no point in time there will be any sort of discrepancy between the two. When we want to leave a game, we expect the server to know he's in a game. And when we want to join a game, we expect the server to know he's not in a game yet. Then we're going to say pName equals player name. Now this may seem a little confusing. I know the scoping in GML is at times hard to figure out. In our object player, if his identifier is the same as PID, I mean you can say self sort of story. I'm just going to put self there so we can see. If self.playerIdentifier equals PID, that's that one. Then self.playerInGame equals not self.playerInGame. Then pName equals self.playerName. So you can see how that's kind of strange. At times we're using variables within scope of object player, and at other times using variables in scope of the script. It all has something to do with using temporary variables within scripts. It's pretty complicating. If you don't understand anything about that, check out the documentation on that. It's something it's going to take a bit to wrap your mind around. Also, this is where most of your problems can come about. So if your game isn't working and you're pretty much 101% sure that it's not something you've done, chances are it's just because the variables you're trying to access are in a different scope, or you've got two variables within the same scope with the same name, and GameMaker doesn't really know which one you're talking about. So I'm going to remove all these selves. So just keep that in mind. Sometimes what it's better to do is find the player ID, find the instance of object player, grab its actual ID. I'm talking about its ID like that, not its player identifier or PID. Grab its actual ID and then do things with that ID. It's a lot more reliable. And I'll actually do some of that later so you can see exactly what I mean. So anyway, we're looking through all our object players, finding the one that matches, and we are setting his in-game status to the opposite of what it was. So if he was in a game, he isn't now. If he wasn't, he is. So that's what it is. Then we need to tell other players about this change. So I'm going to go to our controller. I'm going to go to our networking event. I'm going to grab this 4. There's no point writing code if we've already got it somewhere. I'm going to paste that in over here. Now that it's there, let's just change it slightly to make actual sense in this context. So we're getting our stored player socket, that's the same. Now we want to make sure that we're not telling the person who's changing his state that he's changing his state. I mean, he knows that already. So if stored player socket is not equal to socket, and this socket is the socket up here that's passed into this script, then send some stuff. And when we do send stuff, remember we're sending to the stored player socket, which happens to be every user except the user that sent this message. And we're going to write a 6. We are writing the PID as well as the name. Now you're probably thinking, why JPI? Why are you writing the name? What's going on here? If the player leaves, why do I need to know his name? Well, what happens if a player joins? We need to know his ID. We need to know his name so that we can construct him on our side. So there we go, we've got ID in the name. If the player is leaving the room, well then we don't really need this, but it doesn't matter. We're sending it anyway. So now that that's done, let's also think about something else. Well, if I'm joining a game, I need to know about all the players that are currently in the game. Otherwise, on their side, I'm going to be a new instance of a remote player, but on my side, I'm going to be all alone. And only every player that joins from that point on, I will see. So that's far from ideal. Tell me about other players. So again, let's grab a for. Let's grab our stored player socket. Let's grab this one again. So just as this says, well, if it's someone else and not the person that sent this message, that's what I'm doing here. So I'm going through everyone else with object player. If self dot player socket equals stored player socket. See, I'm making use of self there. Another thing that I'm going to make use of to make an example here is player equals ID. And before I actually do that, I need to initialize a variable here called var player equals no one. Cool. So before, what we did was we had to wrangle with scoping and make sure we understand exactly the way scoping works, especially when we are using variables within a script. But to be on the safe side, and this is actually something that the GameMaker manual recommends you do, is you create a temporary variable called player, assign it to no one, you go through all your players, and using some sort of identifier, you identify the player that you want. So I'm using self here just to make sure that this player socket means the one in object player, and everything other than that means everything in the calling object, well, in the calling script. If this was a calling object, then you'd use other, right? But not in this context. Then I'm setting the player instance to that ID of object player where this condition is met. So now I've got the exact player I want. We now know that there can be no confusion. I can say if player is not equal to no one, right? So if this all passed, then it's not equal to no one anymore, it's equal to an actual ID. Then I can say if player.player in game. See, now I have access to all the variables stored in that player instance, that exact player instance I'm looking for. And then let's copy this, paste it in here. We're writing a 6 back to our client, just like this one's doing. See, can reuse this. We are writing a player.player identifier. We are writing a player.player name. And we're writing that packet to the socket of the person who sent this request initially. Okay, so we've got a lot of brackets going on. This is getting a little bit confusing, and that's okay. It actually is. This is what networking is all about. You're going to be getting all kinds of headaches as you do it along, but it's very much worth it. So let's run through this piece of code again. I feel the need to do so because it is kind of crazy. We're getting our ID of the person that's changing his state. He's either joining the room or he's leaving the game room. We don't know we don't know the name of this player, but that doesn't matter. So we're going to initialize a variable over there. We're going to cycle through all instance of object player. We're going to find the one that's changing his game state. Then we're going to set it to the opposite. We're also going to grab his name. Then we're going to tell every other player that this person has either joined the game world or left the game world. Now I need to make this abundantly clear. When I talk about game world, I'm not talking about the game. I'm actually talking about the room where things happen, where the movement takes place, where we actually need to be sending and receiving coordinates and whatnot. But we need to know the state of all the other players. So they need to know that we're now joining or leaving the game world that they're in. So as long as they're not the person that sent this message saying they're changing the state, we send them some information. Then now that I've changed my state, I need to know about the other players. So we cycle through everything, grab the socket of the player stored. If it's not me, the person that sent this message, then I'm going to grab the player instance of the person that's represented by this socket. If it's not a blank person, and if that person is in game, then send me his details. Alright, so we're going to be getting a 6. It's going to be a player identifier. Geez, we're going to get a lot of errors. Sorry guys, I've been trying to type this really fast. I'll sort that out later. And that's a 6. So let's jump into the client side and do some stuff. Oh. All right. Case 6. Break. Let's create lots of space. Again, we are getting a PID. Let's mark that in there. We're getting a P name. That's going to be a string. There we go. Again, we're going to be using var instance equals no one, similar to the whole player story. With the instances of object remote player. If remote player ID is this ID. So if we grab in that, so we need to grab that instance of remote player, instance equals ID. If instance is not equal to no one, oopsie, no semicolon, bracket. Only if we're in the game world. I mean, you could do this on the server side, just stop it from sending this message, but anyway, I'm just going to do it over here. So don't tell us if we're not in the game world, it doesn't really matter, I'm just going to ignore it. So if instance exists, object player, this is actually local player. Remember, an instance of object local player only does exist if we're in the game world. See, this is a cool thing. We don't want a local player if we're not going to be using it. I'm not going to be making remote players and local players invisible if they're in different rooms. That's just ridiculous. Let's only create these instances if they need to be there. And here we need to create a remote player for that player to be represented in our room. var remote player. You'll notice I'm bouncing around with the different ways of creating instances. You can use var remote player and then set its variables using remote player dot this and that, or you can use with instance create and then open your brackets and then shove in the code there. These are the kind of things you can do. It all depends on what you're comfortable with. I like to just jump around with them. It doesn't matter. They all do the same thing. There we go. And then we can say object remote player dot remote player ID equals PID. Then we can say remote player dot remote player name equals pname. Oops, that. And there we go. We have a remote player instance to represent the person joining our game world. And that's, oh, actually this needs to be equals none. If he doesn't exist, so if it can't find him, then create him. So what happens if we can find him? Well, if we can find him, then it obviously means that he's leaving the game. So we're going to put an else here. I'm going to say with instance. I like to wrap these around in brackets. Instance destroy. And he's gone. Completely gone. Exploded, if you will. And then we break. So the last thing we need to do, quite thankfully because this tutorial is going on for quite long, is change our state. As a player, how do we send that 6 to the server? Well, in my local player, if I, oh, not that, in my local player, if I press escape, then let's let that represent me leaving the game world. Tell the server we're leaving the game world. So let me just grab something here. There we go. That. So we need to write a 6 we need to write our global player ID. And that's that. Simple, huh? Let's just make sure that things work out. 6 and a player ID. That's going to fly over here to the 6. Read in our player name. It's going to do all its magic and set us to the opposite of what we are. And then once that's done, let's send ourselves room, go to room, main menu. Okay, so guys, that is it. Let's save everything. Now, I'm just going to test this on one instance joining, just to make sure we haven't broken anything else. So fingers crossed, hopefully this works without any errors. But who knows, they could pop up. Typos happen. Here's an error. It's complaining about a font not existing. So let me just create that. FNT1. Let's make it an 18. Good. Abort. Run again. Why did I call it FA1? Okay, change that, definitely. There we go. Stop complaining, will you? Excellent. Server status 1, total client 0. Server is up. Let's try connect one client to that. If you notice any lagging, it's probably because my notebook is currently about to overheat. It's really, really, really hot. So any latency jumps and that stuff is probably just because it's having a hard time here. What do we got? Doesn't know player ID counter. Object controller. I think this is on our server side. Player identifier equals player ID counter. Player ID counter. Line 12. Networking event. Let's just create something called var PID equals player ID counter. See, this is the whole scoping problem happening. There we go. Definitely no confusion there. Okay, so yeah, we shouldn't get any weird scoping problems over there. And things actually look fine for these two cases. Oh, actually we're missing an S over there. Okay, cool. So let's try this out again and hopefully we don't get any more errors. So there we have our server. And our client. There we go. So the 1 represents their ID. So even though they're not logged in or registered, we do still have an ID for them. The 0 represents whether they're in a game or not. So that is set to 0. When we click join game, once we're in the main menu, that'll change to 1. And the space in between, this blank space, will be their player name. So let's go log in. JP 1 2 3 4 5. Log in. Cool. I've got my name. 1 JP0. Now when I click join, this should change to 1. Oops, error. What does it say? Doesn't know player. In networking controller, line 90. This is probably supposed to be players. Yeah. Okay. Line 90. So it's line 90. I think it mentioned the handle incoming packets. So it's coming in through here, then it's being passed to this. So let's go to line 90. 90 global player. It's supposed to be global players. Okay, up there again. Okay, players. Alright. Let's try this again. Alright, join. Cool. So that changed to 1. So if I push escape. Oh, we have a problem. Socket. And variable get socket. Network send packet, socket, it doesn't know what socket is. Of object local player. That's supposed to be object controller.socket. So let's go back to object local player, that's in our client. So yeah, we left there even because this one crashed. So there the server is disconnecting players properly. That's really cool. So local player, escape pressed. This one is supposed to be object controller.socket. Alright. Save. Alright, got our client. Let's log in again. See what happens. Join. 1. Escape. 0. See? 1, 0, 1, 0, 1, 0. So when it becomes a 1, that's going to be telling all other players in this room that I'm there. When it becomes a 0, it's going to tell them all to destroy me. So now that we know that we haven't broken anything and things are working with one client, let's create another one and join. So here we are, we've got 2 clients running on one server. You can see 1020. Let's log him in. I think one was Sam, if I can remember the other user that I registered back in the day. And JP. 3, 4, 5. Log in. Cool. So there we go. 1 JP 0270. So when I join, there we go. He's in game now. If I join over here, he's in game. So we see me, we see Sam, we see me as Sam, and we see JP. So I haven't done player movements in this one, and the positions are random. But when I push escape on one of them, see, the other client is disconnected from our game. Pretty cool, huh? And just like that, we are creating and destroying instances of remote player depending on how many players are joining and when we join. So I hope you found this tutorial educational and helpful. Please feel free to comment, rate, and subscribe for more of the very best GameMaker and actually networking tutorials. I don't know if there are any other ones like this,